y square equal to a raised power cos inverse t. If I multiply these two, okay, so we will obtain multiplying these two. This is first one, this is the second one that we take. So multiplying these two equations, these two, we get x square y square equal to a raised power sin inverse t. Now when bases are same in multiplication, powers are added. This is cos inverse t. A raised power sin inverse t plus cos inverse t. This is nothing but a raised power pi by 2. Why? Because we know that sin inverse t plus cos inverse t is pi by 2. Sin inverse theta plus cos inverse theta is pi by 2. Okay, so we obtain here x square y square equal to a square a raised power pi by 2. Now differentiating with respect to y, okay, what we have to obtain minus y upon x. So differentiating it with respect to x, so differentiating it with respect to x in this case, we get this is x square first as it is, differentiation of y square the first function as it is, second differentiation y dy dx. This is 2y into dy dx plus y square as it is. If it is not, x square is 2x equal to 0. Differentiation constant is 0. Here is for power 2 is 0. Therefore dy dx, now separating dy dx, you will obtain minus y square into 2x, 2 into y square x divided by this 2y into x square. 2 cancels out, 1 y cancels out, 1 x cancels out. This is minus y upon x. So answer is obtained. This is dy dx is minus y upon x. Okay, it's proved. So this is one of the ways which we can, the two ways we can differentiate it. Now let me take the second way also. How the second way can also reach this answer. Now let me take the second way of differentiating this. If I differentiate this with respect to t, differentiating these with respect to t, we get now first dx dt. Yes, this is a raised power sin inverse t. Is sin inverse t. Okay, half power. So first half will come into a raised power sin inverse t as it is, into differentiation of sin inverse t. Sorry, a raised power sin inverse t. A raised power sin inverse t as it is, into log of a to the base e, the base log of a to the base e. But differentiation of sin inverse t, because sin inverse t is not t, so we have to differentiate it again. That will be 1 upon under root 1 minus x square with the differentiation of sin inverse t. So what we obtain here, log of ae, because differentiation of a raised power x is a raised power x into log of ae, log of ae, basic, whatever basic. But here in place of t or x, we have sin inverse t. We have to differentiate sin, so this is sin inverse t, not x. I'm sorry, this is 1 minus t square. Okay, so this is the final differentiation of dx dt. Now again dy dt, differentiating second. This is also in the same way, 1.2 power will come. Then, I'm sorry, this is minus half power will left over. Similarly here, a into a raised power cos inverse, sorry, cos inverse t power half will remain there, minus half. Okay, first we will take this power because it was under root, half power will be there, so whole power of this is minus half left over. Again differentiating a raised power sin inverse t, sorry, here cos inverse t, that is in the same way, a raised power cos inverse t into log of ae. Now into differentiation of cos inverse t again, this is minus 1 under root 1 minus t square. These are the two differentiations. Okay, the first one I will note down, then it will come in the denominator because half power is in negative sign. This also will come in the denominator. Let me take them or now obtain dy dx. Therefore, this implies dy dx equal to dy dt oblique dx dt. So that is nothing but dy dx is this much. This is with minus sign 1 upon 2. This in the numerator and this will come in the denominator. We will have these two steps in the numerator. A raised power cos inverse t and log of AE divided by this under root 1 minus t square into this A raised power cos inverse t in the square root. Okay, divided by this value. This is again 1.2 positive sign. Okay, A raised power sin inverse t into log of AE, so log of A to the base E. So log of A to the base E be divided by these two. This one under root 1 minus t square into under root A raised power sin inverse t. A raised power sin inverse t. Okay, so these two. Now under root 1 minus t square cancelled out. Log A cancelled out. 1.2 cancelled out. So A raised power cos inverse t. This one is x square. You can substitute that. Or let me, okay, this is also there. The inverse A is under the square root of power this, and this is 1 power. It will come in the numerator. Okay, so let me write it again. So we obtain dy dx is equal to with minus sign because minus sign is there. So this is A raised power cos inverse t. Okay, under square root A raised power half. Only half power will left over. This is A raised power square root minus 1 t with the square root. This will come in the denominator. I'm sorry. Why this? There is cos sin inverse t. Okay, right there. Right, it was there. So that is this must divided by what we have to reach up to y. Okay. It's all right. Divided by A raised power sin inverse t. Sin inverse t divided by under root A raised power A raised power sin inverse t. The same type of question. It will give us very simple question. A raised power under square root cos inverse t. For this half power will come in the numerator. Divided by in the root of with minus sign. A's raised power sin inverse t. Okay, they are nothing but minus y upon this is y, value of y, A cos inverse t square root divided by x. This is x. So we have obtained the same answer, another method which we have obtained after directly differentiating with respect to t. Okay, now the last question. Let me solve that also. So there are different methods, but answer must be same. We have to reach up to the answer. Then the methods are same. Methods are correct. Okay, solving methods are good. Now let me take the last question, 12th one, which is nothing but if x equal to, let me do this hurriedly, secant theta minus cos theta. Okay, and y is, what is that y? Y is secant raised power n theta minus cos raised power n theta. Okay, then prove that. Very interesting question. And prove that. So the answer is given to us x square plus 4 into dy dx whole square whole square equal to n square into y square plus 4. This is, or we can say that dy dx square equal to n square divided by y square 4 upon x square plus 4. Okay, so that is answer x square plus 4. Okay, now let me take the questions. This is the answer. Differentiating the given functions with respect to theta, in this case variable is theta. So differentiating these with respect to theta. With respect to theta, because theta is the parameter here. So dx d theta is equal to how much? This is secant theta. Differential of secant theta is sec theta into tan theta minus differential of cos theta is minus sin theta. It will be plus sin theta minus plus sin theta. Now if I take here that tan theta common, it will be sec theta plus if I divide sin theta by tan theta means sin theta upon cos theta. So in the numerator we will get only cos theta. For sin theta, let me write here sin theta upon sin theta. Here it was tan theta in the denominator. We are divided by tan theta, taken common from this. But here it was there was no tan theta in sin theta. We have divided by tan theta. Dividing this by tan theta. Tan theta is expressed in terms of sin theta upon cos theta. Cos theta has come in the numerator. Tan theta cancel out. This way, we are left with tan theta, secant theta plus cos theta only. Okay, now let me take this as first equation. Second one, dy d theta. We have differentiated these two again. This is nothing but n into secant n power 1 into theta. Now because sec theta is not theta, so differentiating it again, we get sec theta into tan theta. Okay, minus cos n theta, first differentiated as taking at x raised power n, it will be n into cos raised power n minus 1 left over into differentiation of cos theta is minus sin theta. Okay, so again taking tan theta common. You have tan theta common. If we take n tan theta, n is also common. N tan theta we have taken common. We are left with sec theta into sec raised power n minus 1, so that will be sec raised power n theta 1. Because we have obtained with sec theta 1 more, the power will be only tan theta, n theta. This is minus 1 plus sign. We are left with we have taken tan theta common. Again, tan theta means sin theta upon cos theta. Cos theta will come in the numerator, and n and cos theta 1 we have taken common. So the tan theta we have taken common. It will be nothing but cos with power theta. Okay, minus 1 plus sign. Why? Because if I divide this by tan theta, that means tan theta upon, okay, sin theta cancel out, and cos theta will come in the numerator, so we will get cos n theta. Okay, so dividing this second equation, dividing second by first, we obtain, and let me write it here. Okay, so dividing first by second, this second by first, dy d theta, dy dx, sorry, dy d theta divided by dx d theta is equal to this n tan theta into secant n theta plus cos of n theta divided by tan theta only plus secant theta plus tan theta plus cos theta. It was like this. So what is the values of tan? Okay, so let me Right then, okay. Tan theta cancel out. This is n divided by dx is. So if I make a square of them, then it will be there. Second, okay, sec theta. In the denominator we have sec theta plus tan theta. Second, n theta plus cos of n theta divided by second theta plus cos of theta. Okay, so we can write it as, if I write it as whole square form or squaring both sides, we will get d by upon dx whole square, squaring n square whole square of this, but this is second. Now squaring these two equations, I mean these left hand side, right hand side, okay. This is sec n theta plus cos of n theta whole square divided by sec theta plus cos theta whole square. Okay, that will be n square into, okay, this is whole square of this can be written as sec n theta for the value of n. Okay, sec theta minus cos theta of sec n theta minus cos n theta. So this is sec n theta minus cos n theta. If I write down sec n theta minus cos n theta, okay, whole square of n with plus sign 4 into sec theta cos sec n theta cos n theta. That leaves only one. This can be less sec n theta whole square of n. Okay, sec n theta cos n theta. This is 1. In the denominator also we can write it as whole square of this is nothing but sec theta minus cos theta whole square minus plus 4. This is x plus 4, x square plus 4. This is y square plus 4. If this is 1, this is also will be 1 sec theta into cos theta. Okay, so we have obtained. dy dx whole square. This is nothing but n square into, this is y whole square plus 4 divided by x square. This is x square. X is sec theta minus cos theta. Sec theta minus cos theta whole square plus 4. Okay, so now we can cross multiply this. This is the answer obtained. Now in the next topic I'll discuss about in next lecture. What is the next lecture? Next lecture will be based on first principles. Okay. Now what the differentiation of different functions, trigonometric and inverse trigonometric functions or simple functions with respect to on their respective variables, but by first principle, using principles, first principles, okay, or the basic definition of differentiation. That I'll take the next lecture. It's very important, okay. That's the base of the whole differential calculus. So I'll discuss that. That is not to be missed by this one. Okay, then see you in the next lecture. But before that, we have to revise all these questions. Okay, practice them a lot because they are very, very helpful in case of exams. Okay, then see you in the next lecture.